determine the state. How to determine the state? There will be a few cases. So just now I mentioned you cannot use temperature and pressure, these two dependent intensive properties. You can only use any other two independent intensive properties. For example, now I give you these two. They are independent. Pressure and enthalpy are given. Okay. Once you know these two given, you need to check. What state. So how to check? Then you have to find the values for 100% liquid and 100% vapor. Remember how to find it? So from the steam table, you have that column. Please try to learn how to use the steam table properly. I need to highlight again, the steam table provided to you, there are 3 types of steam table. First one. This is the first type. The first column is a pressure, right? So it's a pressure list. Okay, according to the pressure. This is saturated steam table. So you have another one behind is the first column. Okay, the first column is temperature. So this is the temperature list. Slightly different. For the temperature list, you will be able to find more information here, this column. If let's say you want to find what is the specific volume for liquid and for gas, you need this column here. Please take note, the volume here, you have to divide it by 1,000. You see, you have a factor here, 1,000. So means your actual volume for liquid should be this reading divided by 1,000. For vapor, should be this value divided by 1,000. So for liquid, usually it's very low. It's 0.001 something. So you see the range. The change is very minor. Correct? So just now I said why in that region for compressed liquid you cannot see very big change. So the volume change is very minor. Okay? Almost constant. Okay? So this is the one you need to use a lot if you need the specific volume. Please remember it's in the temperature list. Okay? So this is the second table you need to use. But if let's say it's superheater, then you have to use the superheated steam table. That is the next one, right? Okay. So please, once you have this info, you have to check what is the HL, what is the HG, right? Okay. So after you find that two value, you have to compare. So if let's say it happens, the given enthalpy just equal to that of liquid, so it means it's 100% liquid, or we call this saturated liquid. Or if let's say it happens to equal to the gas, so means 100% vapor or saturated vapor. If let's say it's in between, so if it's in between means it's a mixture, then you have to apply this equation to find either to find the quality, or the quality is given, you can find the total. So if it's higher than the gas, than vapor, means it's superheated. So you only have these 4 cases. 4 cases. Some of you say, can it be here? If this is lower than this. Is it possible? Yes. If this one is lower than this, we call this either sub-cool or compressed liquid. This is a new thing. Right now, I think this part is a little bit new to you. So it means if it's below the liquid, 100% liquid, that will be subcooled or compressed liquid. Then for this, how to find the value? You use the liquid one. Okay? Because just now I mentioned the changes below that is very low. Okay? So if it's subcooled or compressed liquid, you can use that value for the 100% liquid one. Okay. So this is usually you only have these few cases. If you understand this, the given parameter can be specific volume, can be enthalpy, can be entropy. Alright? Can be anyone. But usually you will have one, either pressure or temperature. So is it possible if I give you another tool? For example, I give you a volume and enthalpy. Also can, but it's more difficult to do. Usually will be a pressure and another parameter, or a temperature and another parameter. Okay? Now let's take a look at the example here.
What was already?
Let's see this example. Here in this example, you need to mark the points on the PV diagram and label the temperature for these few cases. You have three, GTC, right? How to do it? Still the same. So for T equals to 20, V is 57.8. You need to go to the temperature list to find at 20 degrees what is a V. Can you all quickly check? Can you all quickly check the steam table, please? What's a V? Can you all quickly please check the steam table? So I need to go to the temperature list. Temperature list is here. Okay. Temperature equals to 20 here. Then I need to check the volume, right? Don't forget the volume you need to divide it by 1000. So you see here? So this is for 20 here. This is the value, right? So after divided by you divided by 1000, what is the value? 57.8. Is it just nice?
Yeah.
Is it the same? So what does it mean? What does it mean? It's 100% vapor. So how do you display on the PV diagram? Where should it be? You have a saturation curve, remember? Which part? This side, right? For vapor. Okay? So you need to So please, when you sketch, we need to sketch this. On PV diagram, sketch the saturation curve. Anyway, try to remember there is a maximum. No need to be exactly the same shape, but at least it should be a curve with a maximum point. Okay? And then you find this point should be somewhere here, right? Okay? So your answer should be here. So that's your A. It's saturated vapor. So this is your A answer. So this is the way for you all to plot or to sketch. Do remember the constant temperature line on the PV diagram should be this way, should decrease. Constant and decrease. Okay? So means the pressure decrease, the volume should be higher. Again, don't draw wrongly. The trend of this line should be decrease, because when the pressure decrease, volume will be bigger. Okay? So this is the first one. The same. Second one, how to do? Then you need to check for pressure equals to 600 kilopascal. What is the internal energy for liquid and vapor? Right? After you checked and you find this is below the saturation, so we call this compressed liquid. So it will be somewhere here. How do I know my B here roughly I should draw above? 600 kilopascal is how many bar? Anyone can answer? 600 kilopascal equals to how many bar? How many bar? 6, yes. So you see here, for T equals to 20, you can check what is the corresponding pressure. Should be quite low. So if you check for temperature equals to 20, the pressure is 0.023, right? Are you all following my question? Yeah, this line is for 20 degrees Celsius. It means the pressure here, correspondingly pressure will be 0.023 only. So definitely your B should be above, because this one is equivalent to 6 bar, right? 600 kilopascal is equivalent to 6 bar, right? So it should be here. Then now you check under 6 bar, what is the U? What is the internal energy? Can you check, please? Under 6 bar, what is the internal energy? For liquid is 669. Did you find? Hey, everyone, did you find? 669, right? Now it's 550, so it should be below. Okay? Now, next. Please tell me where should be the line, above or below? Above or below? Above, because this is 800 kilopascal, right? So it should be above this, correct? And then T is, then you have to check under 8 bar, what is the saturation temperature? What's the temperature, please? Any answers? Yes, 170.4, right? So it means now it's superheated. Okay? How to draw superheated? Yeah? So you draw a horizontal line first. This line means for this pressure. So this pressure, the corresponding temperature here should be the saturation temperature. Correct? So it's 170.4. Now your temperature is higher, it's 250. So you should have another line like this. Okay? 250 should be higher than this. So you can indicate here what is the temperature here you found. Can you indicate? The temperature you found for this dotted line here should be 170.4. That is your saturation temperature for this pressure, 800 kilopascal. So now your actual temperature is 250. Remember 250 should be higher, right? So you draw that cross with your pressure. This is your point. So this will be your point C. So the point C will be superheated. Now roughly you understand how to present the points on the diagram. So here we have a different things here. You have a 100% vapor, you have a compressed liquid, you have a superheated. Okay? On this PV diagram, the level is lower temperature and the lower pressure, the line should be lower. Okay? Higher temperature, higher pressure should be higher. Okay?
U. Tadi dia cakap U. That's why the
Any questions?
Because it's smaller.
No, Everybody okay? You have this week. You have the tutorial question 2 is to follow this way to find where is the point. Actually, you know how to find by using a steam table. Okay, but you just translate the information on this diagram. That's it. Okay, let's carry on. Example 4.2. This one is more straightforward. You see here, it's already mentioned. A saturated steam vapor liquid mixture. Okay, so it's already a mixture. So for mixture, what is important? Once you see a mixture, what does it mean? What does it mean? You need to know the quality, right? Okay? So how to find the quality? You see here, you have a temperature already. Because it's mentioned, this is saturated steam. So means very straightforward. Please check your temperature list, steam table, 250. Okay? Then check the specific volume. Now you see the total volume is 0.04 meter cube. Mass is 9 kilogram. Are you able to find the total specific volume of this mixture? How to find? What is the specific volume? Tell me. How to find? This 0.04 divided by 9 kilogram will give you the specific volume. Is it correct? Yes. A total volume over the mass will give you the specific volume, right? Right? Yeah. Try to do that. Okay? Now, we check for the steam table. So this is, hold on now, I will come back. So you go to this steam table. This is the temperature list. You go to 250. Okay.
Sabrina.
So 250 is here. Alright, I found it up. Then you check. For 250, you need a specific volume. So specific volume is the last column here. This 2. Did you find? Don't forget, both you need to divide it by 1,000. So what is your actual reading? Actual should be 0.00125. Another one will be 0.050111. Correct? After you find that, you go back. So what you need is calculate the specific volume. This is a total of this mixture, means a total of liquid and vapor, right? Then you need to check for 250, what is this? Just now I showed you already. Okay? Then you calculate the steam quality. You must calculate the steam quality first. So to calculate the steam quality, this is the specific volume. Then this is vapor, this is liquid. Okay? So only after you find this, then you can calculate other things like enthalpy, entropy, internal energy. So what is the pressure? It's very obvious here. It's saturated, right? So from the temperature list, the steam table, you can directly find the pressure. So pressure should be 39.7 bar.
You are not like China.
Any questions? Please, for any type of question, you should follow this rule. Try to find out the value for vapor and liquid, then compare. But for this question, it's very straightforward. Already given is a mixture. So means you have to find the quality first. After you find the quality, you can carry on to calculate all the other properties. So far, okay? Are you okay? Did you find the pressure from the table? You just directly from the table, you can read the pressure directly. Okay? Okay, now let's move on. Okay, so the rest will be same. You just find enthalpy for gas and liquid, entropy for vapor and liquid, internal energy. Then you just use the same formula. Then just calculate. You will find the three properties.
Oh my god, I thought we got it already.
So the same formula for enthalpy. This is for entropy. This is for internal energy. I already said you need to memorize one. If you memorize one, you can memorize the rest. So means X quality times this for gas, then 1 minus X times liquid. Please plus. I found some of you in your quiz, lecture quiz, some of you use minus. Here. Here. Please just remember you have liquid, you have vapor. You need to add together. That's it. Then you should know how much is liquid, how much is vapor, how many percent. want to verify? Can you all quickly check the steam table? 250. Can you all quickly check for the steam table temperature list? 250. What is your reading of H and entropy? Don't read wrongly. Please take note, be very careful. Slightly different for the two tables. If you check the temperature table here, 250. Here, 250 is here. This is your reading of pressure, 39.7. And then you have this column. Please read carefully. This is H, L. This is H, G. Then you have a delta H. Don't read wrongly. You should read this column for liquid and this column for vapor. This is for the enthalpy, right? But the internal energy is not listed here in this table. For internal energy, you have to go to the pressure table to find. So here what we have enthalpy, we have entropy, but don't have internal energy. Okay? Here. So you go to the pressure list. You may not have 250 exactly. Let me check. You have this one. Okay. What I found is this 250.3. Okay. So roughly, you can use this to estimate. This is your internal energy. You see the reading from there, 2602, and it's the same, right? So you can use this value. Okay? And for the entropy, you can use this tool. Did you find? Or you use the time, the temperature list of the two values. Also okay. Okay? Alright? Okay, so this example is for you all to practice on how to apply the steam quality for a mixture, right? Okay, let's move on. Are you able to find the values already? Please? Double check. Oh, this one is 2793. Typo here. That's wrong. This is so this one actually you see here this two value is the reading from the pressure table, slightly different from what you read from the temperature table. So these two are from the temperature table. But if I check directly from the pressure table with these two, so it's the same. Both acceptable, yes. Okay? Just now I checked already, it's exactly the same. Yeah. 2.797. Yeah. Now ready? expression. Steam at 2.5 bar. This one is a little bit difficult. You see here, you have a new term here, isentropic compression. Anyone
What
can
is
also
this?
see what is isentropic process?
Same
Which one is counted?
entropy.
Entropy is counted. Yes. Yes, entropy is constant means this steamer before compression and after the entropy should be the same. Okay? But the problem is I need to know the entropy first, right? Otherwise I cannot decide anything. So please, you see here, initially is 2.5 bar. I don't know what kind of state. Then the final is 6 bar 200. Can you all quickly check now? 6 bar, what is the temperature? Saturation temperature? Can you all quickly check, please? Enter 6 bar. What's the saturation temperature? 158.8. Did you find? Yeah. Now it's 200. So tell me what state? Superheated. Okay, go to superheated table now. For 6 bar, 200. Look for entropy. Did you find? What's the value? Please, everyone, when I ask you to work out, you better practice now. What's your reading? 6.968. You find? Yeah. So what does it mean? It means your original steam at 2.5 bar should also have this value of entropy. Correct? Because entropy is constant. Correct? So now for your initial, you have 2.5 bar. Can you go to the 2.5 bar again? The pressure is 2.5 bar. What is entropy for liquid and vapor? Please, 2.5 bar. Hey, everyone, can you all practice now? For 2.5 bar, what is the entropy for gas and liquid? Did you find? So, what can you all determine? Okay, please, for this type, here because it involved a compression process, you need to draw the diagram. There is a change from initial and final to final. So, you have to determine the state first. But now what we can determine directly is the final state. So final state, just now I mentioned already, you go to the steam table under 6 bar, the temperature, saturation temperature you find is 158.8. Now the temperature given is 200, already higher than this, so it's superheated. So if it's superheated vapor, you should choose the superheated steam table to find the entropy. Okay, so after you find this, you should go back to your initial and you find initial at 2.5 bar, you check the steam table, you find for liquid, the value is 1.607. For vapor, it's 7.053. Now the value, this S1 should equal to S2. So it means it's in between the two values. So what does it mean? It means its saturated steam is a liquid plus vapor mixture. It should be because this value is higher than this, lower than this. Here, the final state, I purposely use the red color you see here because it's superheated. Superheated, too hot. So here, any problems to find this? Give you a few more minutes to figure out all the values here. Okay, now can you tell me from here what we decided? What is the initial temperature? Can you decide already? What's the temperature? For 2.5 bar, the corresponding saturation temperature is 127.4. Right? So you will have this answer already. The second, determine the initial composition of steam. What does this mean? What does this mean? The initial composition means you need to know the steam quality. Are you able to find it? You see, you have this S already. You have this for liquid and for vapor. Okay? Then the last one will be to mark the initial and final state on the diagram. Okay, let's see this. So because S2 equals to S1, it's in between, right? You know it's a mixture, so you can find the temperature directly. So this one will be very straightforward. We compare already just now. And then we calculate, we find the quality. Then how to stand on the diagram. So on the diagram will be roughly your point should be here. This is your initial.